We propose SIGNeRF, Scene Integrated Generation for Neural Radiant Fields. SIGNeRF allows us to edit existing NeRF scenes by either transforming already existing objects, like for example here the stone statue into a grizzly bear, or by generating entirely new objects into the scene, for example the rabbit on the bottom right. SIGNeRF does so in a controlled manner, meaning for a grizzly bear that we can really select the region we would like to edit, and for the rabbit, pick a precise location, place a proxy object into the scene where we would like the generation to appear. SIGNeRF is faster, more flexible, more controllable, and even achieves higher quality results compared to previous methods. But how does it work? SIGNeRF utilizes the power of image diffusion models, more specifically an in-painting version of ControlNet. This version allows us to specify with the mask where we would like the edit to appear, and with an additional condition, here a depth map, stick more closely to the original geometry. This allows us here to turn this person into a Batman. While this is great, we can't simply apply it, for example, to an entire NeRF dataset and generate an edited version. As you can see here, if we query ControlNet with images from different positions, we receive images that are vastly different and inconsistent, not suitable for 3D reconstruction. However, and here comes our first core finding, if we combine those images into a single image, also for the condition and masks, run it through ControlNet, we receive an edited version that is vastly more consistent. We call this reference sheet generation. But the question remains, how can we convert an entire NeRF dataset into an edited version? We can't simply make a huge reference sheet and run it through ControlNet, as we have space limitations. Therefore, we propose our second core technique called reference sheet update. With it, we take an already existing reference sheet with an empty slot and corresponding condition and mask grid. In this empty slot, we place an image from the NeRF dataset, run it through ControlNet, and receive an edited version that sticks closely to the reference sheet. We repeat this process over and over again for the entire NeRF dataset and receive an edited version that is consistent with the reference sheet. Now we disclose how I could use those techniques for scene-integrated generation. Here is our pipeline. We start with an original trained NeRF. Then we place a proxy object in our scene or select the region we would like to edit. Further, we place reference cameras into the scene that capture the object from multiple angles. We use those reference cameras and render out the image, the condition, and the mask. Then we place these images in the corresponding image grids and use reference sheet generation to generate a consistent edited reference sheet. Importantly, this reference sheet acts as a preview of the to-be-generated object. Therefore, at this point, we can quickly iterate over multiple reference sheets and choose the one we would like to be generated. After choosing a reference sheet, the next step is to update the entire dataset. Therefore, we either choose the existing NeRF cameras or sample new cameras. We again render out these cameras, place them into the empty spot of the reference sheet, use reference sheet update, and generate a version of the image that is consistent with the reference sheet. We repeat this process over and over again for all cameras within the scene and receive at the end an edited dataset. Lastly, we fine-tune the NeRF with the edited dataset and receive the edit within our NeRF scene. To conclude, we discovered a novel consistent image generation technique we call reference sheet generation. With it and our dataset update strategy, we can edit an entire NeRF dataset. We use this in our scene-integrated generation pipeline to either edit objects within the scene or generate new objects into the scene. With the simple techniques, SIGNeRF allows for fast and controllable scene-integrated generation. In the next video, we will highlight our results.